Hi everyone, welcome to the conversion of binary to decimal. So binary to decimal conversion is done to represent a given number in binary system to its equivalent in the decimal number system. So binary number has a base of 2 because it has two digits to represent a number. These are 0 and 1. On the other hand, decimal number has a base of 10 because it has 10 digits to represent a number. These are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have here two methods on how we are going to convert the binary number into its equivalent decimal number. These methods are the positional notation method and the doubling method. So suppose we are going to convert the binary number 1011010 into its equivalent decimal number. Then how do we do this? Okay, so we first use the first method, which is the positional notation method in converting our given binary number into its equivalent decimal number. Okay, so how do we do this? First, we are going to list out the powers of 2 for all digits starting from the rightmost position. So starting from here, we are going to list out the powers of 2 for all digits. So we have how many digits? So we have here 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we're going to start from 2 to the 0 power, then 2 to the first power, then 2 to the second power, then 2 raised to the third power, followed by 2 to the fourth power, then 2 to the fifth power. Next is 2 to the sixth power, and we have here 2 to the seventh power. So after this, we are going to write the equivalent value of the power of 2. Okay, so the equivalent value of 2 raised to the 0 power is 1 because any number raised to 0 power is always equivalent to 1. The equivalent value of 2 raised to the first power is 2. The equivalent value of 2 to the second power is 4. The equivalent value of 2 to the third power is 8. The equivalent value of 2 to the fourth power is 16. The equivalent value of 2 raised to the fifth power is 32. The equivalent value of 2 raised to the sixth power is 64, and the equivalent value of 2 raised to the seventh power is 128. Then we are going to write the digits of the given binary number below their corresponding power of 2. So we have here 1, 0, 1, 1, 0, 1, 1, 0. Okay, and then after this, we are going to add the equivalent value of the power of 2 which has 1 under them. So here, 128 has 1 under it. 32 has also 1 under it. 16 has also 1 under it. 4 has also 1 under it, as well as 2. It has also 1 under it. So therefore, we're going to add 128 plus 32 plus 16 plus 4 plus 2. And the sum is equivalent to 182. So this 182 here is our converted decimal number given this binary number. So 1011011 to the base of 2 is equivalent to 182 in decimal number. Okay, so let us now use the second method, which is the doubling method in converting our given binary number to its equivalent decimal number. So we will also be using this given binary number, and this time we're going to convert this into its equivalent decimal number using the doubling method. Okay, the first step is we are going to write down our given binary number. So we have here 1 0 1 1 0 1 1 0. Okay, starting from the left, we are going to double our previous total and add the current digit. So our previous total is 0 since we haven't started yet. And our current digit starting from the left is 1. Okay, so we are going to double our previous total, which is 0. Okay, so that means we are going to multiply 0 by 2 and then add the first digit starting from the left, which is 1. Okay, so we have here 0 times 2 plus 1. So the result is 1. So 1 here is our previous total now. So we are going to double this by multiplying it by 2 and then we're going to add the next leftmost digit. Okay, so the next leftmost digit is 0. Okay, so we now have 1 times 2 plus 0. The result is 2. So 2 here is our previous total now. So we are going to double this by multiplying this by 2 and then we're going to add the next leftmost digit. So the next leftmost digit is 1. Okay, so we have here now 2 times 2 plus 1. The result is 5. So 5 here is our new previous total. Okay, so we're going to double it by multiplying it by 2. Okay, and then add the next leftmost digit which is 1. Okay, so we have here 5 times 2 plus 1. The result is 11. Okay, next, we're going to double this 11 by multiplying it by 2 and add the next leftmost digit. So the next leftmost digit is 0. So we now have here 11 times 2 plus 0. The result is 22. Okay, then we are going to double this 22 by multiplying it by 2 and then add the next leftmost digit which is 1. Okay, so we have here now 22 times 2 plus 1. The result is 45. Then we're going to double this 45 by multiplying it by 2 and add the next leftmost digit which is 1. Okay, so we now have here 45 times 2 plus 1. The result is 91. Okay, and we are going to double this 91 by multiplying it by 2 and then we're going to add the last digit which is 0. So we now have here 91 times 2 plus 0. The result is 182. Okay, so using the doubling method, okay, the converted decimal number of this given binary number is also equivalent to 182. So these are the two methods in converting binary to decimal.